we have seen compound interest as a specific case of successive percentage changes. There is another approach to view compound interest as, and that approach is called interest on interest. This approach is probably more important than the successive percentage changes approach. In fact, in quite a lot of GMAT and GRE question papers, rather than writing compound interest, they would just mention that the bank offers interest on interest, right? So it's pretty important for us to understand how compound interest is a case of interest on interest. What do we mean by this, right? So we have taken down the same scenario what we started compound interest with. 1000 rupees is kept at 10% per annum. Now we know the meaning of compounded annually. That is, at the end of every year, the principal gets updated. So first year is the original value 1000, 10% of 1100 gets updated, 1100, 10% of this is 110. 110 will get added, so this will become 1210. So third year I'll get 10% of this value, 121. We know this table, right? What we are going to learn now is just focus on the interest part. Unlike simple interest, where the interest was same in every year, 100, 100, 100, 10% of the original 1000, compound interest is increasing. Spend a little moment to see how is the increase. Oh, so if I just look at it like a small arithmetically the difference, there's an increase of 10 rupees. Is there an increase of 10 rupees again? No, there's an increase of 11 rupees. Next time, do we think the increase is going to be just 11 or is it going to be a little more? If here it's 10, here it's 11, here it would be a little more. Obviously, don't be so naive as to think it's 12 and so on. You know, the next year is going to be 1331, so 133.1, which is a little more than 11 altogether, right? So why is this compound interest increasing? What is that pattern of increase is what we are going to learn here. So we will learn it by comparing successive years only. Again, let me highlight it here. We are going to compare only a year and the next year. So we'll call a previous year and the next year. These are the only 2 years we'll compare. They could be the 6th, 7th, they could be the 14th, 15th, they could be anything, but they need to be consecutive. So we'll start off with first and second. In first I had 1000 rupees was my principal, 100 I got the interest. In the next year, rather than look at this as a opaque figure 1100, could I look at this as made up of the 1000 rupees of the previous year's principal and why does it become 1100? Because I add the interest of the previous year. 100 rupees gets added to this, hence it becomes 1100. If on 1000 I was getting an interest of 100, would I get on this 1000, would I still get an interest of 100? Obviously, because the rate is same and I am considering on the same 1000 part out of it, right? But will I be getting only 100? No. So what I would like to think is I definitely get the 100 because that part of the principal remains, but the principal is also incremented by this amount itself. So I'll be getting an interest on the 100 also at what rate? 10%. 10% of 100 is 10, which is the additional part that I get. And what is this 100? This was nothing but the previous year's interest, right? So I look at it that 100 I do get and this extra 10. This extra money that I get is nothing but the interest on previous year's interest. Previous year's interest. So this is the meaning of interest on interest, right? So 100 plus 10 will become 110. Could we do that with a comparison with the second and third year also? Yes, and in the year one we are doing this, forget what has happened till now. Forget the first year, start from the second year. At the start of second year, 1100 was there. I do not know what was the original principal and so on. But this 1100 is definitely going to remain for the third year also. And that will not be all. That will be getting incremented, compounded by what? The interest 110 will be added. This is how I get 1210. Right? On 1100, I would be getting the same interest as 110. So the earlier year that I was getting 110, I'll definitely get that, right? Whatever I started that year as a principal remains as a principal. In addition to that, I would also get an interest, extra interest. What is that extra interest? Because this 110 got added to the principal. So I'll be getting an interest on 110 as well. Interest on previous year's interest. Previous year's interest. Let this be as a phrase, let it be in your mind always, right? Previous year's interest. So 10% of 110, 11 rupees. So 110 plus 11 is 121, right? So if you can extrapolate it to the fourth year, remember in the fourth year without getting the principal into picture, I definitely get 121 plus I'll get 10% of 121, which is I'll be getting 12.1. If we add it up, 21 and 12 will become 33, 133.1, which we know is 10% of 1331, right? So hope you got the interest on interest one now. So there are quite a few questions based upon this concept of interest on interest, and they are very, very easy. In fact, compound interest questions, most of the students fear it because of the formula. Forget the formula. More often than not, questions are the easy variety which you are going to do next, right? And see, they are just a matter of a few 30 seconds or so on. The first of the easy examples, a bank offers an interest rate of 12.5% compounded annually. If the compound interest in the third year is rupees 640, find the compound interest in the fifth year. So it's a case of compound interest. The third year is given to us. So the third year is given to us and it's the compound interest, and that is just for the third year, not in the 3 years together, right? 640, and the question is requiring us to find the compound interest in the fifth year. So we have seen the example in compound interest. It's easier to compare successive years. So one logical way is, rather than jumping from third to the fifth year directly using some formulas, it's easier to think of third to fourth year and fourth to fifth year. That is 2 times we will use consecutive years. So we are getting the fourth year into picture now. In the fourth year, what we have learnt is I would definitely get rupees 640 again. But that will not be all. Since the principal has been updated, has been increased, I would be getting something extra. And what is that extra? That is what we had learned. We'll be getting an interest on this rupees 640 as well, right? That 640 as well as interest on this 40. At what rate? At the same rate of 12.5%, which is nothing but 1/8. So I'll be getting 1/8 of 640, which is going to be 80 rupees. So this extra is going to be the 80 bit, and so 640 plus 80 is 720, right? Now we change and we look at fourth to fifth year, right? Don't say that the next year again the increase is 80. Remember that case of 100, 110, 121. The increase was 10 first, the next year it was not 10, it was 11, right? So let's see what's going to be the increase. So you look at it afresh. So you start from, let's say, the fourth year, the interest was 720. Forget the breakup and so on. So the next year I'm going to get 720 for sure, and I'm going to get an interest on this 720. So I'm going to get extra 1/8 of 720 this time, right? Which is going to be 90. So I get an extra 90 rupees, which is going to be 810, which is my answer here, right? So it's a simple enough question. Just keep going successive years. This is too piecemeal an approach. The question was not asking us for the fourth year. Then why find this out? Why unnecessarily find it out? Why find 1 year then next year? Can I capture all this working in just one expression? Let's see. Rather than do this 1/8 of 640 is 80 rupees and add 80 to 640, 720, 1/8 of 720 is 90 and add and go vertically. Let's just look at it horizontally, because that is the framework that we have set up sort of. So what is exactly are we doing? So third year, in the third year, the compound interest is given to me as 640. And what am I doing is, I am finding 1/8 of this 640, that is 12.5%, 12.5% of 640, and I'm adding it back to the 640, right? That is the calculation that we have done. Now, isn't this simply as good as there's a percentage increase of 12.5%, And if I look at it as a percentage increase of 12.5%, we are very fast and very adept at multiplying factors. So 1 plus 1/8. So take the 640 common, 1 plus 1/8, which is nothing but the multiplying factor. So could I say 640 is multiplied by 9 by 8? And to get this value, so 8 8s are 64, 8 9s are 720, right? This is how we get this. And in the next year, what are we doing? Are we again doing that same, the base value 720 plus 1/8 of 720, which is equivalent to say there's an increase of 12.5%. And this is of the new value. So this is again a successive, right? Out over there. An increase of 12.5 is nothing but into 9 by 8. So if I did not want to find the intermediate value, could I just say this is equivalent to 2 increases of 12.5% successively, a 12.5% increase, again a 12.5% increase successively. And how do I handle this? 640 into 9 by 8 into 9 by 8, right? So 8 8s are 64, that's a 10, 9 9s are 810 is the direct answer that we get, right? It's not just about saving a calculations or so on. It is about a concept, right? And what is this concept? What we understand is the compound interest in successive years also increases at the same rate, right? What I want you to boil down is, if you look back at this 1000 rupees and the rate 10%, we know amount is going to be principal into 1.1 raised to n. So in successive years, there's a 10% increase. The 1000 rupees becomes 1100. There's a 10% increase. This again increases by 10%. This is working in amount. But what we learned is the compound interest also behaves the same way. In the first year, I'm going to get 100. In the second year, there's a 10% increase in this. That I'm going to get 110. In the next year, there's again a 10% increase on 110. Also, the compound interest is also increasing at the same rate. This is what we learn, right? And this will help us typically when we have to go reverse, as in the next example. The example reads as, a bank offers a compound rate of interest of 20%. If the compound interest in the 5th year is rupees 900, find the compound interest in the 3rd year. It's identical to the solved example we just solved. Except that the compound interest is given for the 5th year and is asked for the 3rd year. There it was the reverse way around, right? And if you have if I capture the situation, the 3rd year, sequentially this is going to come earlier, so I am writing this, but I do not know this value. It increases something, there's a 4th year intermediate and then there is a 5th year, and it's given that the 5th year compound interest is rupees 900. If you have understood what we just learned, these values boxes do not refer to the principal and the amount, they refer to the compound interest, but it doesn't matter. Compound interest also in successive years increases at the same rate as the rate of interest, right? So if the interest is 20%, compound interest is also going to increase at 20% annually out over here, and a 20% increase is as good as multiplying by 6 by 5. So next one more year, 6 by 5, and the value given to me is 900. I want to find the initial value, right? Now this is a simple example to solve. There's nothing left out over here. Or let me just point it out, just the word of caution. You cannot find 20% of 900 just because the latter value is given. Let me find 20% of 900, and what do I think? I'll subtract it. The subtraction part is okay in our mind, but this 20% is not of 900. It is of the previous value. This is where that approach goes wrong. And this approach you have been emphasizing right from percentages, and then cost price, selling price, profit percentage. You have done quite a bit of this, so I hope you do not have that in your mind, right? This is the last time we'll be doing. When we want to go reverse way, the best way is the multiplying factor way. So 6 will cancel it with a 150, 6 25s are. So 25 into 25, x is going to be 625 rupees is my answer, right? And the only other possible way in which the question could be framed is, if the compound interest in the 3rd year is rupees 10,000 and the compound interest in the 5th year is rupees 11,025, find the rate. So the setting is same for 3rd and 5th year, but what is different is now the two values are given, the rate is unknown. It doesn't matter really. Look, if percentages fundas are pretty obvious, this simply means I start with the 10,000. which is the compound interest in the third year, and every year it is increasing at a rate, but I do not know the rate, so I just put in a factor, so it's just multiplied by some multiplying factor, and that multiplying factor appears twice, because from third to fourth year it increases by a certain rate, and fourth to fifth year by the same rate, right? This is why multiplying factors are very useful, right? Specifically when you do not know, and you don't have to really write that multiplying factor is 1 plus r by 100 and so on, right? You can avoid it just by reminding you that it is a factor. So it boils down to just do some calculations out over here. Needless to say, 25 looks as a prime common factor, so I'm just doing it. 25 will cancel this with a 400. 25 fours are 100. Will leave out 10. 25 fours are again 100. 25 ones are, and 441 as well as 400 both are squares, so taking the square root, which is 21 by 20. So the multiplying factor is 21 by 20. That is, it's a percentage increase of, remember, 20 to 21, that is an increase of 1 on a base of 20, converting it to percentage, 5%. So the bank offers 5% rate of interest, right? Therefore I said these questions are very, very easy. There is another set of questions which are as easy as this, which is what we'll take up next.